So thank you so much for joining us for our exclusive virtual field trip for Legacy Club members. That's going to take us from the wild coast of Virginia down to the waters teeming with fish off the Florida Keys, and then back up to the abundance of marine life that can be found in the live bottom habitats of Grays Reefs National Marine Sanctuary off the coast of Georgia. I'm excited that we have so many of you, our Legacy Club members, tuning in from all across the country. And as we mark the 30th anniversary of the Legacy Club, I want to express how inspired we are each and every day by your extraordinary commitment to safeguarding our natural world. We could not achieve the scale and impact of our work without your generous support, so thank you. I'm Elaine Lyles, a Legacy Club Stewardship Manager at the Conservancy, and I'm joining you from my home in Central Florida. As we begin, I do want to acknowledge that I am on the land where I am sitting is the homelands of the Timucua and Seminole people, and I pay my respect to the traditional indigenous inhabitants and stewards of these lands, as well as to their ancestors. And before we get started today, I do want to go over just a few brief Zoom housekeeping notes. First of all, you're going to notice a toolbar at the bottom of your screen where you have several options, and I'll point out just a few of these buttons for you. First is the CC icon. You can click on this anytime throughout the presentation to turn closed captions on or off. You'll also notice a chat icon, and this is where my colleague John is going to be sharing helpful resources and additional information for you throughout our field trip. And you're also going to see the Q&A icon. Please click on this button to submit your questions anytime throughout our field trip. We do want today's event to be interactive, and we're going to try to get to as many of your questions as possible. And we'll also be collecting all your questions throughout the presentation, and we'll get to the Q&A session at the conclusion of our presentation. In the top right-hand corner of your window, you should see a View button, spells out View, V-I-E-U. If you click on this, if you're having trouble seeing the full slides on your screen today, click on that button and you can change to Fit to Window, Full Screen, 100%. You can toggle between those options to see what's best for your view today. And finally, we will be recording today's presentation and sharing with everyone afterwards. So from Virginia down to the Gulf of Mexico and the Caribbean, TNC has staff collaborating to address ecosystem-wide challenges with a cohesive and united approach that leverages the organization's diverse expertise and resources all across the region. Today, you're going to get to meet several of my colleagues who are tackling marine conservation issues as we journey up and down the southeastern coast of the U.S. First, we have Mary Conley joining us from South Carolina, and she has been with TNC for 17 years. She currently serves as the Southeast Marine Conservation Director. Next, we have Jill Bieri and Bo Lusk, who are joining us from Virginia's Eastern Shore. Jill is the director of TNC's Volganal Virginia Coast Reserve and has been with TNC for just under 10 years. And Bo is a coastal scientist leading the marine restoration work at Virginia Coast Reserve and has been with TNC for about 16 years. And finally, we have David Moss joining us from Florida. David joined TNC a little over 3 years ago and serves as the Florida Fisheries Project Manager. With that, Mary, I'm going to turn it over to you.
Great. Thank you so much, Elaine. And thank you all for joining us and for your continued support of the Nature Conservancy. We're very excited today to share our marine conservation work across the Southeast United States during this virtual field trip. The Nature Conservancy's Ocean and Coast Network was created to facilitate collaboration across our Southern Division from Virginia to Texas. Our ocean waters and the species that live within them do not see jurisdictional boundaries. And the Ocean and Coast Network was designed to acknowledge that fact by collectively working on building the science that informs our work, engaging partners and policy at a regional level, and sharing resources and lessons learned to enhance our conservation impact. Next slide. The region covers over 50% of our contiguous United States shoreline. And there are some common issues as well as natural resources that we are working to conserve and restore across this amazing place. This includes the seagrasses, salt marshes, and mangroves that make up our coastal shorelines, oysters and coral reefs that enhance our nearshore systems, and a variety of fish, marine mammals, sea turtles, and bird species. And the region is facing some common threats. Things like climate change, which is impacting ocean temperatures and seeing changes in our storms. Coastal development that is both influencing our water quality, as well as increasing the number of people who are coming to the region and making use of these natural resources. On today's trip, we'll get a chance to see our work that's happening in 3 places along our coast. That's part of what's happening across the entire region. We hope you find it enjoyable, and I look forward to the discussion at the end. On that note, I'm going to pass the floor to Jill, who's coming into us from the Eastern Shore of Virginia. Jill?
Great, thanks, Mary. And I'll echo Elaine and Mary and thank you all for joining us and your continued support. It's always a pleasure to share the screen with colleagues across the Ocean and Coast Network, and it's always a pleasure to talk about the Virginia Coast Reserve. And you'll see that we're zooming in to Nassauattucks, where Bo and I are sitting today, the headquarters of the Virginia Coast Reserve on Virginia's Eastern Shore. 53 years ago, the Nature Conservancy and partners had the foresight to begin protecting what we now call the Virginia Coast Reserve. The first barrier islands were purchased in 1970, and this intact barrier island system now encompasses 18 barrier and marsh islands off the coast of Virginia that are practically undeveloped. The focus of the Virginia Coast Reserve's land protection broadened after the initial purchase of these islands to include the southern portion of that Delmarva Peninsula, the nearshore marine system, and the shoals of the mainland's Bayside, Chesapeake Bayside, thus encompassing the entire eastern shore of Virginia. Barrier islands, salt marsh, mud flats, upland forest, in total 133,000 acres of conserved and protected lands on the 75-mile-long peninsula, surrounded by the Chesapeake Bay and the Atlantic Ocean. It really is the longest expanse of coastal wilderness along the east coast of the United States. Pretty incredible place. Next slide. And with the protection of this vast coastal wilderness comes responsibility to manage the system for species that rely on the barrier islands, the marshes, the mud flats, and even the upland habitats to survive. The Virginia Coast Reserve works hand in hand with federal and state and academic partners to effectively protect and manage migratory bird habitats and other populations at local and regional scales. And we play a big role, an integral role in developing, prioritizing, and implementing research that has uncovered information critical to ensuring the resiliency of many species of conservation concern. We have lots of long-standing partnerships. It's pretty incredible here, along with this coastal protection. We are partners with the University of Virginia's long-term ecological research program, the Center for Conservation Biology, the Virginia Institute of Marine Science, and many more. And with our partners, we seek new opportunities to combine research, applied science, community engagement, and really serve as a living laboratory for coastal sites around the world. Next slide, and hopefully this will help you get into the virtual field trip and feel like you're here with us on the Eastern Shore, because it is here at the Virginia Coast Reserve that we can demonstrate how our islands, our marshes, and our other natural communities are responding to impacts of climate change. Impacts like increased sea level rise, more frequent and more intense storms. And because of the longstanding land protection that we've highlighted that surrounds these coastal bays in Virginia, as well as our relatively small rural population. And by the way, our community is so connected to nature, both socially, culturally, and economically. We indeed have some of the best coastal water quality and water clarity in the world. Because of that, at the Virginia Coast Reserve, we are fortunate to be able to successfully experiment with marine restoration techniques and combine with world-class research to figure out how to reestablish critical marine habitat, such as oysters and seagrasses. As director of the Virginia Coast Reserve, one of the greatest assets I believe we possess is our incredible staff, from land protection to marine habitat restoration to community engagement. Our staff works passionately to engage with partners in our community to continue to build on our 43-year-old legacy. My colleague, Bo Lusk, is one of those VCR staff members that just so happens to be from an Eastern Shore of Virginia family that has been here for generations.
Bo's story really helps to tell our TNC story. We'll join Bo now in the eelgrass beds in the coastal bays of Virginia.
I grew up here in this system. You know, I grew up on the Chesapeake Bay side of the peninsula. I spent a lot of time in the water over there and a lot of time in the water out here on the seaside on these islands. I was really aware of all the grasses that grew underwater, both on the Chesapeake Bay side and on the seaside. My grandmother grew up in the same area, and she taught me some about fishing and crabbing, and we would wade in the Chesapeake Bay eelgrass beds with dip nets catching crabs when I was a little kid. You know, she told me there's eelgrass here in the bay, but there isn't eelgrass on the seaside. And I was like, yeah, Grandma, I know. I go out there, I never see it. And she goes, but there was eelgrass there when I was a little girl, and it all disappeared. And I think she's who made me aware in the first place of that difference. The eelgrass here on the seaside disappeared when she was a teenager, you know, in 1932 or 33. In the 1920s, there was a wasting disease, and it was particularly tough on the eelgrass that we have right here, because our salinity here is really high. There are no rivers dumping any fresh water into this area, and high salinity made it easier for that wasting disease to harm the eelgrass. Over the course of that time, pretty much while the wasting disease was here, folks on the eastern shore were starting to figure out how to harvest bay scallops that depended on that eelgrass for habitat. In 1930, Virginia produced more bay scallops than any other state in the United States. But at the same time, that eelgrass population was declining from the wasting disease and maybe getting beat up a little bit by scallop dredges. After 1930 and 31, there was a big decline in our bay scallop harvest. 1932, an even bigger decline. The reports from scallop fishermen were that it was hard to find any eelgrass at all that year to fish in. The storm of 1933, a big unnamed hurricane, finished the job in taking out all the eelgrass.
And it did a pretty successful job of getting rid of all that grass. We lost here in our system what used to be just huge, vast, vibrant, productive underwater meadows that basically just became barren underwater mudflats for almost the next 70 years. And it wasn't until the late 1990s that Dr. Robert Orth at the Virginia Institute of Marine Science first started really seriously trying to restore eelgrass to our coastal bays. And he was able to come up with a brand new method utilizing seeds instead of planting shoots that worked pretty darn well. But to get this project, all of this restoration work up to the scale that we wanted it to be at, he needed a lot of helping hands. And that's where the Nature Conservancy became involved, initially by leading big groups of volunteers every spring to help collect the shoots that are producing the eelgrass seeds via mask and snorkel and stuffing them in mesh bags like this. And this process is actually going on by other members of our team right now as we speak. Today is probably going to be the last day of eelgrass seed collection for the 2023 season. Next slide, please. All of the shoots and material that we collect come into the Nature Conservancy's eelgrass seed curing facility and get dumped in the big tanks you see here. And this is where we're going to take care of all this material for the next few months. If you look in the bottom right-hand corner, you'll see a close-up of one of those shoots, and within it, you see the developing seeds. And those seeds are going to finish developing in the tanks. They'll pop out of those shoots, and they're very dense, so they're going to settle down to the bottom of the tanks, and we can sieve out all of the rest of the material and keep those seeds safe until the fall. Next slide. And it won't be until fall when seeds germinate. And that's when we go to plant them. This is really the easy part of the process. You see how tiny these seeds are. So planting millions of seeds doesn't really require a whole lot of people. We literally ride around on the bow of the boat and toss them out like we're feeding chickens or something. And it works great. The system here was really primed for the success of the eelgrass because of all the land protection work that the Nature Conservancy had done here historically. And so far in this project, we've planted a little over 600 acres of seeds, and they've been so happy they've spread on their own to around 10,000 acres of eelgrass meadows total within the system. Next slide.
Eelgrass is important for habitat for a lot of the creatures that we like to eat and fish for. Eelgrass is important because it helps hold sediment in place and protect our shorelines against erosion. And eelgrass is important because it helps to store a lot of carbon that we don't want in the atmosphere to help in one way to protect against increasing greenhouse gases. Seagrasses globally, we're losing at the rate of about a football field every 30 minutes. So no matter what the gains are right here, the net change in grass is still negative around the world, and it's so important for so many communities around the world. So whatever we can learn here to either inform or inspire more seagrass restoration globally, I think is really the big, most important impact of all of this. The Nature Conservancy started its work here 52 years ago. We've protected absolutely fantastic water quality in these coastal bays. I hate to say it, but you're not gonna be successful at restoring any sort of seagrass if you don't have decent water quality. And the Nature Conservancy's work over the past 52 years is really what set the stage for this to be able to be the largest successful seagrass restoration project in the world.
So I think for me personally, it's good enough reason to do this restoration work, just for sentimental reasons, to bring the system back to the way it was when my grandmother was a teenager. But we need to look for other good reasons besides things that are important to just me here, good reasons to do all of this restoration work. And we're fortunate that by having been restoring this habitat for about 20 years here, we've created this fantastic living laboratory that is being taken advantage of by our academic partners, such as Virginia Institute of Marine Science and the University of Virginia, to help measure what the big changes are resulting from all of this work. Physically, the water has cleared quite a bit as a result of planting the eelgrass. The water in South Bay, where all this started, is about twice as clear as it was at the beginning of the project. We're finding out that eelgrass can actually enhance shellfish growth, which is important because we have a really vibrant hard clam aquaculture community here on the Eastern Shore. And as ocean temperatures warm, we become more and more concerned about increasing ocean acidity, which can make it tougher for clams and oysters to grow. And this eelgrass underwater at a local scale can actually help to buffer against that ocean acidity, like a great big Tums dumped in our coastal bays. And they've also been able to measure the rates that carbon is stored and sequestered in these eelgrass meadows. And eelgrass stores a surprising amount of carbon in the soils. It can store carbon at rates equal to or even much higher than terrestrial forests. And we're well on our way to having some of the first ever verified carbon credits based on a seagrass being sold by the Commonwealth of Virginia within area that we've restored as part of this project. Next slide. But besides all that physical stuff, there's all the stuff that lives in the grass that's coming back. Just last summer, we had our first verified sighting of a green sea turtle utilizing our eelgrass beds. The bay scallops that we lost when we lost the grass in the 30s are being restored, are being brought back to Virginia by the Virginia Institute of Marine Science. And they're seeing a lot of success. And it isn't crazy to think that somewhere down the line, we'll have a recreational bay scallop fishery in Virginia, if not a commercial scallop fishery. And the grass beds are just tremendous as a nursery ground for fish, whether it's forage fish like the silver sides you see in the top right-hand corner, or the fish we like to go fishing for, like the juvenile black sea bass that you see in the bottom right-hand corner. These restored habitats are really functioning like they're supposed to in producing all these young fish. And the fish are then not just staying here, but moving from our nearshore habitats to offshore habitats, or moving up or down the coast. And so with that, we're going to move down the coast to just off the Florida Keys and hear from David Moss.
Thank you very much, Bo. And as Bo just insinuated, is we're going to take things from inshore, offshore. So those wonderful juvenile snapper and grouper, as well as forage fish that love to go into those seagrass beds, and we move offshore to the reefs and wrecks of Florida, Florida Keys in particular. I am a native Floridian myself, and I'm going to talk to you guys about the snapper and grouper work that we're doing here in Florida. Next slide, please. Thank you. Florida, we often say, is the recreational fishing capital of the world. Sorry, Louisiana, but it's true. As we go to the next slide, we can see why. Florida is home to over 4 million licensed anglers in our state alone, approximately 9.2 billion with a B dollars in economic impact just from saltwater fishing. As of 2018, so obviously it's a little bit dated, but over 14 million trips by recreational anglers annually. Statewide, about $7.2 billion in economic impact output, 56,000 jobs supported. So as you can see, saltwater fishing is a huge piece of what we do here in Florida. And we've chosen to focus on a select group of species as well. If we go to the next slide, we chose to focus on what we call the snapper grouper complex, as defined by the South Atlantic Fishery Management Council, which is who manages the fishery species from 3 miles, which is state water limits, out to the exclusive economic zone, so way offshore. There's 55 different species in that complex. Some of the most popular ones that you may have heard of listed here: red grouper, gray or mangrove snapper, mutton snapper, scamp grouper, Goliath grouper, black sea bass, red snapper, yellowtail snapper, and of course black grouper. As I often say, I don't have favorites, but there are some that I like better than others. And one of the reasons that we focused on this group of species is this is the complex of species that is consistently going through overfishing or being overfished. And to put that in its simplest terms, is there are more fish being removed from the resource than can conceivably sustain itself. And one of the main reasons that this is happening is due to something called barotrauma. What happens is fishermen will go fishing, and since snapper and grouper species tend to live close to the bottom, when they come up, they can be affected by something called barotrauma, which is very similar to the bends in a scuba diver. So this is where the gases in the fish's swim bladder expand faster than the fish can expel them. And that causes all kinds of joscillation in different organs. You'll often see the fish's stomach come out of its mouth when you catch it and whatnot. And if we go to the next slide, we can see some examples of that. So starting all the way on the left, that is a speckled hind, and you can see how the scales, I will get that right, the scales look all flushed out and puffed. You can see in the top right there, red grouper with its eyes bugged out, and of course on the bottom right is the red snapper with the stomach coming out. Now the good news is that there are things that we can do to mitigate this or even reverse these effects, and that is with something called a descending device. A descending device is very simply a device that will bring these fish back down to depth, again, just like recompression for a scuba diver, and will really recompress these fish. It will completely reverse the effects of barotrauma, and this is something that actually has been put in place by the South Atlantic Council as a requirement on all vessels in federal waters about 3 years ago. So if you're fishing for any of these species in federal waters from North Carolina all the way down into the Keys and then even into the Gulf of Mexico, you are required to have one of these devices on board. Florida just recently instituted this in state waters as well. One of the reasons that this is mainly a federal requirement is because most of the issues with barotrauma are associated with deeper water, we'll say about deeper than 60 feet or so, which you tend not to find in state waters, with the exception of Southeast Florida, which is where I live. In this video here, we can see different examples of descending devices. That's called an inverted hook device. This is a lip grip style, which is actually pressurized. So you clip that onto the fish's jaw with a heavy weight attached to another rod that you have. And as that brings the fish down, you can set it for different depths, and the pressure will actually cause that device to release. And here we can see an example of what happens when a fish suffers from barotrauma. And if you imagine that almost exactly in reverse is what will happen when you bring the fish back down. Here's a red grouper. You can see its stomach starting to poke out. And believe it or not, that'll completely deflate just like a balloon as it goes down. There's a device rigged and ready as we put it on the fishing rod and we drop it back down. This beautiful red grouper that is too small, so we're going to release it. And as we drop that down, again, you'll actually see the recompression of the fish as it goes down. You can see the fish getting skinnier. I only wish this worked on me, right? As it gets down, and then once it hits the assigned depth that you have that set for, boom, the fish is going to swim off to live and fight, not only to live for another day to be caught again, but also ideally to create more fish, which is great for me, as I really, really love to go fishing. Next slide. And the way that we're going to get this message out, and the way that we've been working through this, is by using anglers as our voice, by using influential anglers, in fact, by using things like YouTube and Instagram and some of the quote unquote influencers in the fishing community to help us spread the word. We were also on a couple of episodes of The Fish Guys, which you can see on Discovery Channel. We have done a couple of podcasts with Tom Rowland, a very famous Florida Keys fisherman, to help us spread the word, so that it's, again, anglers influencing anglers to really affect what we do on the water to help improve our fishery and make sure that it's sustainable for years to come. Next slide. We also have been able to create our own webpage. If you want more information on this, nature.org/Florida Fisheries. You can have links to some of those influencers on there, as well as a lot more information on barotrauma. I have to be very careful when it comes to talking about fish. I really love to fish, and so I can really go crazy and down some rabbit holes and probably occupy everybody's time, which I'm sure nobody wants, as we move to the next slide. And then one of the other areas that we're looking to focus on as we move forward, not just on descending device work, but is what we call data modernization. So the current state of data for recreational fisheries in particular is fairly poor. Unfortunately, it's what we have right now, but what we're trying to do is, again, work with anglers to help be the voice to really improve and modernize the data systems that we have in place for recreational fishing, so we can have really good accountability of what it is that we're doing on the water, not just what we're catching, but certainly what we're releasing and what we're encountering on the water every day. And what's really great, and Mary alluded to this at the very beginning of the presentation, we say on the water all the time that the fish don't see fences. So the fish that we catch and release in Florida don't just stop there at the Jacksonville line. They make their way up into Georgia and offshore of Gray's Reef right there, where we can go and catch wonderful red grouper and black sea bass that Mary will talk to you a lot more about.
Great, thanks, David. And as we move up the coast, we're actually going to move both up the coast to the north, as well as a bit further offshore to Gray's Reef National Marine Sanctuary. Gray's Reef is a hotspot for biodiversity located on the continental shelf off the Georgia coastline. Much of our work in the marine environment is happening in the public trust. That means that it is in places where the authority comes from state and federal agencies. So a lot of our work here is done in that collaboration with those organizations. And an example of that is the National Marine Sanctuaries Program. Gray's Reef is one of 4 designated national marine sanctuaries located within the Ocean and Coast Network, along with the Florida Keys, where we just were with David, the Flower Garden Banks National Marine Sanctuary in the Gulf of Mexico, and the Monitor, which is an archaeological site off of North Carolina's Outer Banks. One way to think about national marine sanctuaries is as the underwater aquatic equivalent to national parks. These are places where you can still go to visit, to fish, but it provides additional opportunities for research and education and smart management of our ocean resources. There are a total of 15 national marine sanctuaries across the US, encapsulating about 620,000 square miles. As we zoom in to Gray's Reef, we're really talking about a 22 square mile sanctuary that's located 19 miles east of Sapelo Island and about 40 miles southeast of Savannah along the Georgia coast. NOAA designated this area as a sanctuary in 1981 because of the diversity of species and abundance of marine life that are found associated with live bottom habitat. The picture on the right is a visual of that live bottom habitat. This is something that's created when you have a structure on the seafloor, something like a limestone boulder or a hardened area or a shelf edge. Along those hardened structures, you get a variety of soft corals, sponges, sea squirts, and other organisms that collect there and really build a reef ecosystem. Here you'll see a picture of that black sea bass that's now traveled with us from the Virginia Coast Reserve down to Gray's Reef. Next slide. But Gray's Reef isn't the only example of live bottom habitat in the Southeast. It's actually a critical habitat that you'll find across our coastline, with spots along the continental shelf, as well as along the shelf break. The map on the right is one that was created by the Nature Conservancy in collaboration with partners as part of our South Atlantic Bight Marine Assessment in 2018. You'll note that there are a variety of spots on the continental shelf, and then almost an edge of live bottom habitats that occurs when the water when the seafloor gets steeper along our continental shelf break. Our work with the sanctuaries is one way that we're working to conserve these areas. Other activities involve working with the South Atlantic Fisheries Management Council on conservation that limits what can happen in the areas, such as not allowing bottom trawling, which can destroy the habitats. We're also currently working on a cooperative research project to monitor fish spawning around select live bottom sites. And we're working to think about how we can avoid placing new and expanding uses in areas such that we've identified as important, including creating a Southeast marine mapping tool, which allows users to understand the habitats and species that are being used in a given area. And these are important fishing spots. So we're looking to work on this with the fishermen, such as what David mentioned. Next slide. So one of the benefits of National Marine Sanctuaries is it brings additional opportunities for research, outreach, and education. Gray's Reef is one of the most studied places along the South Atlantic shoreline. The NOAA Nancy Foster ship, which you see here, conducts annual research trips to the site, and a buoy is located there to get real-time monitoring of the water quality and the seafloor. So let's dive in and go explore Gray's Reef National Marine Sanctuary. On the way down, we acknowledge that the water column itself is a critical habitat, an opportunity to see a variety of species that call the ocean home. On our trip down the 65 feet to get to the seafloor, you may notice things like spadefish and cannonball jelly before arriving at the live bottom habitat that makes the Gray's Reef known. So now that we've landed on the seafloor, we're going to do a quick tour of one of the ledges that makes up Gray's Reef National Marine Sanctuary. You can see here a diverse array of encrusting sponges, soft corals, and other invertebrates that account for the biodiversity of this particular region. Over 1,000 species of invertebrates and 200 species of fish have been identified at Gray's Reef National Marine Sanctuary. And you may be able to spot some of the fish hiding as we travel through. And then at the edge, you'll see us move into a more sandy bottom habitat. That ledge or that edge portion, the diversity of habitats within the given space, is also important in terms of the uses of the reef by the species that live there. For example, the nurse shark that's here hiding under a leaf edge. Nurse sharks are a predator within this system, feeding on a variety of species like spiny lobsters, small stingrays, sea urchins, and squid. On the other side of the size scale, you may spot a seaweed blenny here hiding in some of the coral structure. In this case, we're looking at a species that feeds primarily on algae and is prey for other larger fish species. That predator-prey relationship is something that's been studied at Gray's Reef. Here you see a school of tomtat that are living around that sedge, suddenly moving aside as that same black sea bass comes in to feed. This is research that's conducted at Gray's Reef by partner fisheries biologist Peter Oster, who's actually from the University of Connecticut, which shows that the variety of people who are interested in these habitats really expand across the local area. As we take this final image of a couple other species found in Gray's Reef, one of the things that we think about is the long-term health of this special place. Things like the impact of climate change, which is increasing temperatures, causing population shifts in fish species. And as Bo mentioned earlier, looking at the ocean acidification that may be occurring in the region, which could impact the ability for corals to grow. Another component is water quality. The water quality of these habitats is part of what will allow for the overall health of the species. Studies have shown that river water that enters the ocean along the Georgia coast reaches all the ways to Gray's Reef. So we're going to travel with the loggerhead sea turtle, one of the multiple species that spend part of their times along the coast and a portion of their time out at places like Gray's Reef, to talk about how our coastal conservation work benefits the reef itself. And just like the loggerhead, when we think about this, we need to think about the variety of threats and potential impacts, as well as the health of the overall system in order to conserve these iconic species. This is an aerial shot of the Georgia coastline. And similar to what we saw with some of the images that Jill shared from the Virginia Coast Reserve, you can see the large salt marsh systems, the barrier island beaches, and in this case, the riverine systems that make up our Georgia coast. Georgia has done a lot of protection along these conservation areas, and we continue to work on restoration of populations like oysters and salt marshes. As we go deeper, we can actually think about the Altamaha River. The Altamaha River is one of the largest undammed rivers east of the Mississippi, running 137 miles and covering more than a quarter of the state of Georgia as a drainage basin. It pours approximately 100,000 gallons of water into the Atlantic Ocean every second. So that influence of our upland, our land, our freshwater, and our estuarine systems on ocean health is critical. The Nature Conservancy has been working to conserve the Altamaha River for decades, and more than 50 miles of floodplain are now under protection. So that's going to wrap up our virtual field trip. I hope you've enjoyed seeing some of the places where our marine conservation work touches down across the ocean and coast network, and hearing about the connections between the coast and offshore habitats and how their things are connected across state boundaries. I want to thank you all for all you have done to make this work possible now and in the future. Thanks.
Thank you so much, Mary and David and Bo and Jill, for that really fun exploration highlighting the interconnectedness of these marine habitats, as well as to our work to protect them. It really shows how TNC has a unique position to take our work with our local communities and really scale that up to make an even bigger impact. So thank you for sharing that. Well, I think that's a great place for us to kind of end today. And thank you all again, Mary, Jill, Bo, David, for joining us. We really appreciate you taking the time to share your expertise and give us a glimpse into your office. And thank you to everyone in our audience for joining us as well. We really appreciate you sharing your time with us too. We will be sharing a recording of today's virtual field trip after the event, and it will be available on our nature.org/webtalks page in about 2 weeks, so you can find it there. And if you have any questions that we weren't able to get to today, please let us know. You can email us at lcteam@tnc.org, and we'll be sure to follow up with you afterward. And finally, as we all continue to provide opportunities for you to connect with our work across the globe, we would really appreciate receiving your candid feedback about today's event. There's going to be a brief survey available to you that my colleague John is sharing in the chat. It will also pop up when you leave the webinar, but we would really appreciate hearing your thoughts. So with that, I'm just going to say thank you again for joining us and for your commitment to our mission. Together, we are truly shaping a brighter future for people and nature. So take care, and I hope you have a great rest of your day.